Smokeless chimney, color shift versus opacity, the best flames on the net. While we watch some fire, we're going to take a look at some charts. This is the 10-hour test. The blue line is the temperature of the stove shell, and the red line are the gases going out the chimney. The gases going out the chimney tend to drive the temperature of the stove, so they're always leading the stove. They get hot, the stove gets hot. As they get cooler, you can see the stove gets cooler. We're looking at two lines. The color shift is in red on its own scale with the right numbers. The opacity is in blue with the left values. This is a 10-hour test. You can see that the temperatures, as they get up, you get different and similar numbers with the color shift. Let's look at one specific part to clear this up a little bit. Between these two green lines, there's some data for an event that happened in the wood stove. We're not really sure what happened, but we're going to take a look at that in a different graph. They occur at the same time, and we can isolate that little time component. We can see that at the same time we get an offset of the color and an offset of the opacity. So something happened, it sent out a puff of smoke, and then we get 5 or 6 readings on the color shift before it returns back to its baseline. So there's more information in the color shift than there is in the opacity at this particular data point. While we look at the fire, we'll change graphs here. This is the first 2 hours of the 10-hour test. And you can see that very early in the test, we get high numbers on the color where the opacity is just still building up. We're starting to make some smoke and getting up to the 20% level. And the color is giving us more information earlier into it. There's another point around 60 minutes where you can see, I think I put more wood on, but the opacity drops for a while. However, the color or the wavelength values increase. And I'll highlight those a little better here. I'll also move the lines around. So I've adjusted the scale of lines so they're almost right on top of each other. You can see there's some divergence in the first 20 minutes, and then you can see some divergence in the 60-minute range. And if you can't see it yet, I'll put some graphics on the screen so that you can. Let me get out an ellipse and a rectangle here. Now they're stuck. There we go. So the green rectangle is the divergence of data in the first 20 minutes. And then the yellow rectangle, yellow circle thing shows the divergence in the data between the opacity and the wavelength value or the color shift. Clearly, there's more data at certain times of the test than in the color shift than there is in the opacity information. And that's what I'm trying to show here. I've put the two charts almost on top of each other in this graph. You can see that the peaks and events a lot of times are aligned. However, there are some indicators on the opacity or absorption of light and some indicators on the wavelength offset or the color shift that show that the smoke is changing something in the light, blocking a portion of the wavelengths, and therefore the total wavelength received by the sensor has changed. And I believe the color shift has almost equally as much information as the opacity in a different way. We just have to have a good scientist look at this and tell us what we're looking at. Our next chart is a 8-hour test we ran the next day. And the opacity system just wasn't behaving as well as I'd like. There's a lot of tricky things with the opacity system, yet color is a very easy thing to measure. And what I want to do is go through this and see if we can figure with just the color or the offset. Let's see if we can figure out what happened in this 8-hour test. Let's take a look at the color shift alone and see if we can determine what happened in the stove during this 8 hours. We assume that there was some startup. We had to put some fuel in. Can you see any indicators? Well, let me put some descriptors on this. A bigger chart and some we see that we have the starting time. You see one part where I put a 1.7 kilogram log on, a round log. That's what's been burning on the background. And then there's another point where we put a 2 kilogram split piece of hardwood in. You can see based on the color shift, the indicators, that we can figure out when fuel has been put on the stove and when it's turned to mostly carbon fuel. These are good indicators that we can see with the color shift technique. In summary, opacity, or the absorption of light, is an important factor in measuring smoke. Another method is color shift, where we're measuring either the smaller particles that are blocking a portion of the light or larger particles that are blocking a portion of the light but not all the light, and therefore we get a color shift in the light. This is an important scientific measurement that we need to have good scientists working on so that we can figure out how to make our wood stoves burn clean. Warm homes and clean air for everyone. Smokeless Chimney, www.smokelesschimney.com, Facebook, Reddit, and YouTube.